rotation of the coordinate system. Consider the x and y. Instead of x sub 1 and x sub 2, let's work x and y. This is z. Okay, now x, y, and z, okay, if you rotate x toward z, toward y, you have the xz here, the axis z, okay? Just you use the right hand rule, okay? Now rotate and then you have z. This is I, j, and k. Okay. Consider that we rotate xy, the plane xy, okay, now around z. Okay? Let's rotate counterclockwise, okay, of an angle theta. This is, I'll call x prime, and here y prime. This is I prime, j prime. This is j. Ij rotates by an angle theta. Use the right hand rule, rotate around z axis. Okay. Okay. Now I will find a matrix which correlates, okay, ijk with I prime, j prime, and k prime. You see, they coincide. Okay, k prime and k, they are coincident because we are rotate around the x. Okay, counterclockwise. Now, you see, look, here you have I prime. Here is I. This is theta. How do I project this I prime? I, in the I prime straight line, on this line here, how do I project? Just I prime dot I is equal, in this case, is equal I prime, the magnitude of I prime, magnitude of I, cosine of the angle. Okay? Now, I project I here. Okay? This is scalar quantity. This is 1, this is 1. Okay? This is 1 times cosine of theta. Okay? Now, we will not do this every time I project a vector in one direction and the vector in the other direction. I just look at cosine of the angle. Okay? Now let's write down this relation. So I will project the unit vector I and the unit vector j in this straight line direction here, which I prime lies on this straight line. So I prime is equal. This is I projected in the I prime. This will be I cosine of theta. Okay. Now I'll project j into this straight line here. This I project j here. Okay? Now, if this is theta, this will be theta here. So the projection here will be plus j sine of theta. Okay? Now I will do the same procedure, just projecting over j prime. Now pay attention here because you see, if you project I here, okay, this will be in the opposite direction of J prime. So here it will be minus, okay? Minus I. Now this angle here is theta, this is theta, and this is theta. So this will be sine, okay? Minus sine of theta. Plus, now I'll project J over J prime, okay? And here, the angle theta, this will be a cosine plus J cosine of theta. Then, okay, now here K, okay, coincides with K prime because we are rotating around this axis. Okay? K prime is equal K. Here I can complete here, put 0 K plus 0 K. And here I can put I times 0 plus J times 0 plus K. Now we are ready to write down the matrix. So this is I prime, J prime, let's put here J prime and K prime. This is equal. Now here's the matrix. So I put here I, J, and K. Now I'll write down the matrix. Okay, there's a column vector. There's a column. Cosine of theta plus sine of theta. I'm sorry, let's put it here. Sine of theta and 0. Here minus sine of theta plus cosine and 0. And here is 0, 0, 1. So you see the product, okay, of these two matrices. This is a matrix, this is a column matrix, this is a square matrix, 3 by 3. Okay, 3 by 3. This is 3 by 1. Now, first row times this column is just here. Second row times this column is right here. Third row times this column is right there. So that's a matrix. Now, one very simple point is this. If I have theta here, and here is minus theta. This is plus and minus. You see, when you project here, this is a cosine and this is sine. You see, this side is equal to this side. Okay, let's put a little bit less just to, okay. Now, this is minus theta. See, this side is equal to this side, but this is plus, this is minus. So the sign of this segment is opposite of the sign of the segment. So sine of minus theta is equal minus sine of theta. Okay, we call this an odd function. Okay, now the cosine remains the same. You see, there's a cosine. Okay, so cosine of minus theta is equal cosine of theta. Okay, we call an even function. Okay? Now we can use this result right here. You see, I will erase here. Look. Okay, suppose I rotate now, okay, in the clockwise direction. Okay, then I just change this here, and here will be minus theta here. Okay. Now I just put here. Okay, this this will be ij. This will be ij. Let's write down right here. Okay, I will erase here. Okay, and I substitute theta by minus theta. So instead of I have I prime, j prime, and k prime, I'll have I, j, and k. It's just the opposite. This is equal. Here is I prime, j prime, and k prime. Now I'll substitute theta by minus theta. So cosine of minus theta is cosine of theta. Sine of minus theta is sine of minus theta is minus sine of theta. This is 0. Likewise here, sine of minus theta is minus. Minus is plus. Sine of theta, cosine of theta, and 0. So if substitute plus theta by minus theta, cosine of minus theta is equal cosine of theta. This will be 0, 0, and 1. So you can see clearly that this matrix and this matrix, they are inverse of each other, and if I call, for instance, this T, his will be, let's go C. This will be C transpose. Okay? And you substitute, if this vector here, you have this matrix times this matrix. You see? Then we will get the identity matrix. Okay? Just substitute here. Another important point. You see this column here, the first column? If you square it, you have cosine square of theta plus sine square of theta plus 0 squared is 1. Likewise this one, likewise this one. So here we have 3 orthonormal vectors. Okay? That's the basis. Now, why this vector and this, why they are orthogonal? Okay? Because if you multiply the elements of this column times the element of this column, you're going to get 0. You see, look. Cosine of theta times minus sine of theta will cancel with this product here, sine of theta times cosine of theta. So you have 3 orthonormal vectors. Then you have an orthonormal basis. This. Okay? Likewise, this one is the same. Okay, consider rotation and 2D. Now, I have x, y coordinates and x prime, y prime coordinates. Okay? As we did before, we rotate counterclockwise of an angle theta. We have ij and I prime, j prime. So the relationship between ij and I prime, j prime is just this matrix here. I prime, j prime is cosine of theta, sine of theta, minus sine of theta, cosine of theta. Now, if the transpose of this matrix is equal to the inverse, which it is, because here is an orthogonal and orthonormal vectors, cosine minus sine, sine is plus cosine. Then I take the transpose, I have cosine of theta. This is this case, okay? I take the first row and put in the first column. Here is sine of theta, and the second row, the second column, minus sine of theta, and this cosine of theta. Now, you see, pay attention here on these 2 matrices over here. Now I have a fixed vector. Here's fixed vector. Okay? and I rotate like here. I have x prime and y prime. Is a rotation of xy system by an angle theta counterclockwise, or the right hand rule. See, right hand rule. Now, vector v is a fixed vector, okay? The components of the vector v with respect to x and y axis is v1i plus v2j. See, v1i, see, v1i. And here is v2j. The same vector, okay, the components of the same vector with respect to x prime, y prime coordinates are v1 prime, I prime, v2 prime, j prime. See, v1 prime, the blue one, v1 prime, I prime, plus v2 prime, j prime. They are equal vectors, okay, equal vectors. Now, I will substitute right here, okay, the I prime. You see, I prime is cosine theta I plus sine of theta j. So this is cosine I plus sine theta. Cosine theta I plus sine theta j. This is exactly what is I prime. Now I'll substitute j prime over here. So j prime is minus sine theta I plus cosine theta j. Is right here, minus sine theta I plus cosine theta j. Now I rearrange these terms over here, and here's I. You see, this is v prime, v1 prime, I, cosine theta I. This is minus v2 prime, sine theta I. So I put I here, okay, multiplying both terms. Likewise, j, okay, I have v1 prime sine theta j. v1 prime sine theta j. In this, v2 prime cosine theta j. v2 prime cosine theta j. But v is also v1i plus v2j. You see, v1i plus v2j. So this term over here must be v1, and this one must be v2. So v1 is v1 prime cosine theta minus v2 prime sine theta. I just write over here, look, v1 is cosine v1 prime, in this case, minus, you see, minus v2 prime, and this over here, okay? It's very easy, okay? Now this is v1. Now the same for v2. You see, this is v2. You could write, you put this letter here to see. This is v1 and this is v2. See the whole, this two terms here, v1 and v2. So this v1 and v2. Now, this is I, this is I, this is j, this is j. Now I can put this in using the matrix, okay? We transform the components of vector v, okay, with respect to x prime, y prime, transform this component into the components of the same vector, attention, the same vector v, okay, in the xy coordinates. This is in matrix form. But you see that if you want v1 prime, v2 prime, for vector v, fixed vector, okay, v1 and v2, okay, the matrix cosine minus sine, sine plus cosine, okay, operating or v1 prime and v2 prime yields v1 and v2. The transpose of this matrix, or the inverse, because we are working with the orthonormal basis, v prime 1, v prime is 2 is cosine plus sine. You see, you can look here, okay? Look, v prime 1, okay, is greater than v1. See, this blue one is greater. That's why here is the plus sign. You see? Now, V prime 2, the blue one, okay, is, in this case, okay, is less, the length is less than V2, okay? That's why you have minus over here. Now, let's forget for a while this figure over here. Let's go to this figure over here, in which x, y are fixed system, and v prime moves to v. But we did before that v moved to v prime. Now we want the opposite, okay? V will move to v prime, but theta is an angle which is in the clockwise direction, okay? Now, what was my advice is this: you just put, I will put over here, that I'll have more space. See, look, always you do that. Cosine, sine. Don't put any sign here. This is sine and cosine. Cosine. Then there you put V1 and V2. Now, you see, the minus sign or will be here or here. Okay, there is no other place here. Let's see. See V prime over here? V prime, okay, is this length. The V1 in this case, this is V prime 1, and this is V prime. This is V1, and this is V prime 1. It's greater. No doubt you have a plus sign here. Now, let's look at the y-axis. You see, V prime 2, you see, is less than V2. This is V2, this is V prime 2. Okay, this is V2. V2, right here. So, obviously, there is a minus here. You see? So, this matrix, okay, operating on the component of this vector V, okay, transform the component of the vector V prime. What's the difference between this one and this one? Here V is fixed, okay? Now, the axis moves. Here, the x, y is fixed. The vector moves. In this case, he moves in the clockwise direction. Now you compare, okay? Look, here is a vector V prime 1, V prime 2. This is V, the components of the same vector V1, V2. Look how it's interesting results. Okay. The behavior of a fixed vector, okay, in this case, decomposed into two different systems, just rotating system, is the same if this vector here rotates rotates clockwise on the same angle for the fixed x. You see, compare fixed axis. Compare these results here, okay, with these results here. Okay? Look, and these results here, okay, the axis, okay, x prime, xy prime, it was obtained by rotating counterclockwise xyx. Here, the behavior of this vector here are the same. Okay, look, if I use a rotating axis, okay, for fixed v, fixed vector, is the same if I bring the vector and rotate clockwise in the opposite direction. Because when you move like that, it's the same as the vector move like this. It's the same. Okay, it's a relative motion. That's all. Okay, that's a final observation. Okay, if I have 2x like that, okay, if they move like that, okay, it's the same if I have a fixed vector, a vector moving the fixed axis and the vector move like this, okay? If the axis moves like that, rotating like that, it's the same as if you have a fixed coordinate and the vector moves like that. Okay, that's quite clear. The results shows this. See, v1 prime, v2 prime, v1 prime, v2 prime. This result is for fixed v, rotating the x. This result here, the same result, okay, is for fixed xy, the axis, and move just clockwise the vector v. Okay, rotation of a point around the three axes, x, y, and z, is a very important topic to the area of computer graphics. First of all, let's consider my zx. This is x-axis and this is y-axis. You see, the right hand rule or counterclockwise. Okay, if you rotate x from x to y here, here's my zx. Okay, now this is a cylinder. Okay, suppose I have a point, let's call point A here and point B here. Okay, from A to B will follow this circle over here. Okay, this circle. There's an origin. There's an A, and this is B. This is A, and this is B. Now, I rotate this point around zx. I rotate counterclockwise, and you see that there is a plane here which is parallel to x and y plane. So you have that z of point A coincides with z of point B. Why? Because they are parallel, okay? This plane here is parallel to that plane. So it has the same height, okay? The same height. Now, you see this height here, exactly the same as this. Okay? Let's call this point here A prime and this B prime. And suppose it rotates by an angle, let's call an angle here and an angle there. Okay? This is my angle, let's call theta. Okay? Rotates. In this case, you see, look, using right hand rule or counterclockwise. Now, this A and B prime. You see, this angle theta is the same as this one. Okay? We can see that's my angle theta right here. Now, we can now, okay, have the x and y plane. I'll put over here. Look, x and y plane, and the z-axis, the same thing. Okay, I'm just right here, and the z-axis will be like this. Okay. Now you see, if you move from x to y, okay, counterclockwise, z is pointed in this direction. Okay, that is z. Now I'll put point A. Let's see, point A, and here the circle, and here is point B. Okay, this is my angle theta right here. Okay? This figure is just this one. Okay, now I'm working instead of A, let's put A prime and Z prime. Okay, I know because the rotation is around Zx. Okay, ZA is equal ZB, or it's the same. Okay, ZA prime is equal ZB prime. So if this point here, okay, it lies on the plane XY. Okay, but I'm worried about A and B. That's my focus. Focus A and B, not A prime and B prime. Okay, now as I said before, okay, you see, pay attention that this I call this point here X and Y. This point B I call Y prime and X prime. See? Just now, in this case, the coordinate system are fixed, and I'm moving the point from A prime to B prime. Now, I will do as follows. I'll have my matrix. I have X prime, Y prime, and Z prime. Now, my matrix here, X, Y, and Z. Attention now. X prime is less than X. For sure. Okay, I will erase here and put bigger matrix. I'll write down here. It's better. I have more space. So, this is X prime, Y prime, and Z prime is equal. This is my matrix, and this is X, Y, and Z. Now, I see here, okay, that X prime, when I move counterclockwise from A prime to B prime, I see that X prime, okay, decreases. Okay, so for sure, always we start from cosine. This will be minus sine, and this will be 0 because I'm working the R3 space. Now we see here, when you move from A prime to B prime, you see this Y prime is greater than Y. So I have plus sine here and plus cosine here, and it is 0. And Z prime is equal Z. Why? Because the height, A prime, B prime, they are the same, because I'm moving on this plane here. This plane here is parallel to this plane here. Okay? So this will be 0, 0, and 1. You see how easy it is? How it's quite easy. Obviously, if I move from B prime to A prime, I just go in this matrix here, and I substitute theta by minus theta. That's it. Okay? Now, I will do for the other two axes, Z, X and Y, just looking easily what is going on here. From here, the rotation around the two other axes, Y and Z. You see, this rotation was around Z. Okay, this is X, this is Y, and this is Z. There's my angle theta here, theta and theta. Now, to obtain the rotation, for instance, around the ZX or X-axis or Y-axis, you just follow this sequence here, X, Y, Z, X, Y, Z, X, and so on. Look, after X, I put Y. So this is Y. After the sequence, after Y, I just write Z. You see how easy it will be. Now, after Z, I put X. So now I'm worried about rotation of a point, okay, around X-axis. Okay. Now, instead of theta, let's put phi. This is phi, and this is phi. The figure is exactly the same. So now my plane, instead of X and Y, after x, this will be y, and y will be z. It will be z. Z. Okay? Y, z, you see it. Look there, the right hand rule, or the counterclockwise. Look, if I move here, this is my x-axis. The same figure it is. Okay? Now here I'm working the plane. Instead of theta, it's phi. Okay? Now this is z prime. This will be z, the same. Z prime, see? And here, instead of x prime, it will be y prime, and this is y. Okay, here is the rotation around the x-axis, okay? The rotation in a counterclockwise direction. So this is y, this is y prime. Here is z, and this is z prime. Okay, you can see here that y prime, okay, the length of y prime is less than y. So you can write, let's put here, x prime, y prime, and z prime. So this is a matrix, and this is x, y, and z. You see, because you are rotating around the z-axis, so xa is equal to xb. So in this case, then you put here 1, 0, and 0. You see, the first row times this column, x prime is equal to x, okay? Because 1 times x plus 0 times y plus 0 times z. Now we only have components, let's say, in the yz direction. So then we can put here 0, 0. You see? Now, you see here that y prime is less than y. So for sure, this is cosine, let's call phi, and this is minus sine phi. Let's see why it's minus. You see, this is the second row, y prime. The second row, if you multiply this second row times this column, it will be 0 times x plus y cosine phi minus z times phi. So why this minus? Is because y prime is less than y. Okay? Now, on the other hand, you see z prime, okay, when you move from A to B or A prime to B prime, z prime increases. So for sure, this is prime plus sine of phi and plus cosine phi. So z prime is in the third row. Here, the third row times this column, 0 times x plus y sine phi plus z cosine phi. So z prime is greater than z. That's okay. We call here the rotation around x-axis, okay? The angle is phi, okay? Previously, we had rotation around z-axis, and the angle was theta, okay? We already did. Rotating around y-axis, you just look at here, okay? Look, after y comes z. Let's put z over here. After z comes x. After x comes y. See, that's what I want. I want to rotate. Okay, let's change this name here. Let's put alpha. Alpha here and alpha here. Okay? This is my alpha. Now, after x comes y. See? Y. In this case, fx comes y. I rotate around y. That's good. Now, after y comes z. And after z comes x. So here is xz plane. It's still I'm worried about the right hand rule. In this case, you see, after z comes x. So I will move z from z to x. You see, not x from z. It's z to x. Look, z to x, right hand, comes y in this direction. Now let's see. Now, here's my x prime. See, this is my z prime. This is my x. You see x here, point A, xz. B prime, this, x prime z prime. So the rotation around the yx, okay, after x comes y, after y comes z, so it's z, and after z comes x. That's my x here. Obviously, this will be x and x prime. Here is z, and this is z prime. Now, okay, you have to pay attention that the counterclockwise, you have to move from zx to xx. Why? You see, after z comes x. Okay, we are going in this direction. So zx, if you use your right hand rule, you just rule like that. So this is y here, and from z you rotate to x counterclockwise. Let's change this angle here and call it alpha. Okay, now you see here, when you move in a counterclockwise direction, z, okay, and z prime, this length is less than z. So let's write the matrix: x prime, y prime, and z prime. Here's the matrix I put over here, and here is x, y, and z. That's my matrix here. Now you see, y, there is a plane here parallel to the plane zx. So y of A is equal to y of B, as we did before. Now let's see. We are going to work in the zx plane. So because we are working the zx plane, there is no y component. So y prime has to be equal y. So this is here. See? Now, this is the second row. If you multiply the second row times this column, it will be 0 times x plus 1 times y plus 0 times z. So y prime is equal y. Now let's see. Just look here, okay? X prime increases. So if x prime increases, I'm sure you'll be plus sign. And here z prime decreases. So in this third row will be certainly minus sign. Let's see. Always you put like that. Cosine, it will be 0 because we are working the zx plane. Okay, and also this will be 0. So I put it a little bit here. Now cosine, that's sine. You always do that. Okay. Now cosine, this is sine, and this is cosine. Now let's see the angle. Okay, the angle is alpha. So alpha over here, alpha and alpha. Now let's look at the figure. Okay, at this picture, at this figure here. So z prime is less than z. Okay, certainly. Okay, this will be minus here. This is minus. Why? Because z prime, okay, the length, okay, of this coordinate is less than z. That's why we put minus sign here. You see, minus sign times x plus 0 times y plus z times alpha, because you're working the xz plane. Now, okay, y prime, you see, the x prime the length, the coordinate of B prime is greater than x. So this will be plus sign here. That's called the rotation, okay, around y-axis of angle alpha. Okay, then we reached our goal, okay, is to get the 3 matrix, okay, which rotates around the zx, xx, and y-axis. Okay? And again, I would like to emphasize, okay, that these 3 matrix and also the plane, okay, the matrix which we did before using the plane 2D. It's a very important topic for computer graphics.